In 1901, a group of Greek sponge divers pulled a lump of corroded bronze out of a shipwreck in the Aegean Sea. It looked like scrap. Nobody on that boat knew they were holding a machine so advanced that it would take modern scientists over a century and a small army of X-ray scanners just to figure out what it actually did. It's called the Antikythera Mechanism, and it's not the only ancient object that shouldn't exist for another 1,000 years. This is the story of 4 of them: a bronze computer that predicted eclipses, a concrete that gets stronger the longer it sits in seawater, a steel so sharp and so strong that European smiths spent 500 years trying and failing to copy it, and a weapon so devastating and so secret that the empire that built it eventually forgot how to make it themselves. Here's the strange part. These aren't myths, they're not ancient aliens, and they're not internet legends. Every one of these objects is sitting in a museum right now, or documented in surviving texts, and historians still argue about exactly how the people who built them pulled it off. Let's start with the machine that had no right to exist for another 1,000 years. When researchers finally looked closely at the Antikythera mechanism's insides, they found over 30 interlocking bronze gears, some of them smaller than a coin, cut with teeth so precise they wouldn't look out of place in a 19th century pocket watch. It dates to somewhere around 150 to 100 BC. That's roughly 1,400 years before Europe built anything with comparable mechanical complexity. Think about that gap for a second. It's the same as if someone in the 1600s had secretly built a working smartphone. So who made it? Why did an object this sophisticated come from a culture we associate with marble statues and philosophy lectures, not precision engineering? And if the Greeks could build this, what else did they build that simply didn't survive 2,000 years underwater? That question is where this really gets interesting.
The Antikythera mechanism wasn't a curiosity, it was a working scientific instrument. When researchers at institutions including Cardiff University ran high-resolution X-ray tomography on the fragments in the 2000s, they found inscriptions and gear ratios that let the device track the metonic cycle, predict solar and lunar eclipses, and even display the 4-year cycle of the ancient Olympic Games. Turn a hand crank, and bronze dials would show you where the sun, moon, and known planets sat in the sky on any given date, past or future. Nothing else like it appears in the historical record for over 1,000 years. That's the puzzle. Ancient writers like Cicero mentioned devices built by the astronomer Archimedes that modeled the heavens, so we know this kind of thinking existed. But a single surviving example, this refined, this early, means we're almost certainly missing an entire lost tradition of Greek precision engineering. Workshops, training, generations of trial and error, gone. While the Antikythera mechanism was tracking the stars, on the other side of the Mediterranean, the Romans were solving a very different problem. They wanted concrete that could survive being pounded by ocean waves forever. And somehow they got it. Roman harbor concrete, the kind still standing in structures like the breakwaters at Portus Cosanus, shouldn't still be there. Modern marine concrete typically starts breaking down within a few decades in seawater. Roman concrete has survived over 2,000 years, and in 2017, geologists studying it found something bizarre. Seawater seeping into the concrete was actually growing new mineral crystals inside it, filling in cracks and making the structure stronger over time instead of weaker. Modern concrete doesn't heal itself. Roman concrete apparently did, by accident or by design, using volcanic ash the Romans sourced specifically for the job. 2 civilizations, 2 objects that outperformed what came centuries after them, and we still haven't gotten to the one that made grown metallurgists question everything they thought they knew about steel.
Damascus. Sometime before the 1750s, A European traveler watches a local swordsmith test a blade by draping a silk scarf over the edge and letting it fall. The fabric split in two before it even finishes falling. That blade was made from something called Wootz steel, imported from India and Sri Lanka and forged by Middle Eastern smiths into what became known as Damascus steel. It had a rippling, wave-like pattern in the metal, and it held an edge sharper and tougher than almost anything Europe could produce. Crusader accounts describe these swords slicing through European blades in combat. Then, sometime in the 1700s, the supply of real Wootz steel dried up. The trade routes and raw ore sources that fed it collapsed, and with them, the specific technique died out. For over 200 years, nobody could reliably reproduce it. Here's how they finally cracked it. In 2006, researchers using electron microscopy on a genuine 17th-century Damascus blade found something nobody expected: carbon nanotubes, microscopic tube-like structures, the same category of material modern nanotechnology labs spend millions trying to engineer on purpose, sitting inside a sword forged before anyone knew atoms existed. Nobody thinks Damascus smiths understood nanotechnology. What they had was something almost as impressive: generations of accumulated trial-and-error craft knowledge, specific ores containing trace impurities like vanadium, specific forging temperatures, specific hammering and cooling sequences passed down and refined without anyone knowing the chemistry behind why it worked. Change one variable and the whole effect collapses. That's likely why, when the original Wootz ore ran out, the knowledge simply couldn't transfer to new material. The recipe was in the rock as much as it was in the smith's hands. And that pattern, extraordinary results built on knowledge nobody wrote down in a way we can fully reconstruct, shows up again with the deadliest ancient technology of all: Greek fire. Used by the Byzantine Empire starting in the 7th century, Greek fire was a liquid weapon that could reportedly burn on top of water, sprayed from siphons mounted on ships to devastating effect against enemy fleets. The formula was treated as a state secret, so tightly guarded that it eventually lost even to the Byzantines themselves. To this day, historians and chemists still debate what was actually in it. None of these technologies survived intact. That's the thread connecting all four. The Antikythera Mechanism's engineering tradition vanished from the historical record for 1,000 years. Roman self-healing concrete stopped being made once the specific volcanic ash sources and mixing knowledge fell out of use. Wootz steel died with its ore supply, and Greek fire disappeared so completely that its own inventors eventually lost the formula, guarded so carefully that guarding it became the cause of its extinction. That's the real lesson hiding inside all four of these stories. These weren't gifts from aliens or evidence of some lost super-civilization. They were the product of ordinary human ingenuity, refined over generations by specific craftspeople in specific workshops working with specific local materials. And because so much of that knowledge lived in hands and habits instead of written formulas, it was never as permanent as the objects it produced. A single broken trade route, a single generation that didn't pass the technique down, and it was gone. Modern science hasn't caught up to it, all of it, even now. Nobody has fully reverse-engineered the exact ratios in Roman marine concrete on industrial scale. Nobody has recreated authentic Wootz steel with its full nanotube structure on demand, and Greek fire remains genuinely an open question. So think back to that lump of corroded bronze the sponge divers pulled out of the sea in 1901. For decades, it just sat in a museum drawer, misidentified, easy to overlook. It took new tools, new imaging technology, and people willing to look closer to realize what they actually had. Which raises a question worth sitting with. How many other objects like it are sitting in museum storage rooms right now, mislabeled, unexamined, waiting for someone with the right technology to finally ask the right question. Maybe the most advanced, ancient technology we haven't explained yet isn't lost at all.